Okay, so I'd like to do 11.3 number 67. So this says log base 2 of 3x minus 4 is 3. So what do I start with?
That was solved.
Yeah, so there's a log base 2, right? I want to get rid of that. So I should
Put on both sides.
put everything above a 2. Right? So if I do the 2 to the stuff function to both sides, that's going to give me a 2 to the log base 2 of 3x minus 4. And that's going to be equal to
Same thing?
2 cubed.
Oh, shoot. Oh.
Right? I put everything on both sides, right, in the exponent of a 2. That's me saying, okay, if these two numbers are the same, then 2 to those, right? If this stuff is this stuff, then 2 to this stuff is 2 to that stuff,
Okay, I got it.
right? I'm counting how many times I'm multiplying 2's together. What's up?
So when I'm writing it in my notes, do I want to say raise everything by log base?
I would say put everything in the exponent of a 2. That's really what I'm thinking here. I'm thinking do 2 to the x to both sides.
What did you do with the 4?
What did I do with what for?
Yeah,
Yeah, I
on
haven't.
the other side. What happened to the other side? No?
What other side?
The 2 cubed. Oh.
Yeah, so I did 2, right? 2 to this stuff is 2 to that stuff. Okay, so that's, right, I just had a number and that's some other number. And I thought to myself, okay, if these two numbers are the same, then 2 to this one had better be 2 to that one. Right? I'm just counting how many times I'm multiplying a 2. This one's horrible, of course, right? But this is just 3. So I'm saying, okay, if this thing is 3, then 3 2's multiplied together are the same thing as this many 2's multiplied together. Cool. Now I can say the 2 and the log base 2, those undo one another, right? So what do I get here on the right-hand side? Yeah, I just get the exponent. So I get a 3x minus 4 is, what's 2 cubed? 8. Yeah, and then this is easy to solve, right? So what do I do first?
4. Oh, add 4, sorry.
Add 4, right? So I get 3x is 12.
3 is 4.
And then I divide by 3.
The answer
So I
is
get x is 4, right? And we could go stick that in at the beginning to double check.
Okay, so when it says equals 3, the first one, we always have to use that number to be square or cube or exponent?
So the kind of cue here that I took at the beginning was from this base, that's this number.
Okay.
Really, that's informing all 3 of these options.
Where did you get the cube from?
The cube was because there was a 3 there.
And it's always like that.
Yeah. I'm raising both sides to this 2 thing. Right? Putting both sides in the exponent of a 2. Sometimes you'll do that and it won't be helpful. Like sometimes you'll put a number under both sides and you'll end up with some horribler thing than you started with. So you want to fiddle around with this side sometimes using log rules. We'll do some of that today. Okay. But right now when it's easy, right, when I've got number equals number kind of, I'll just put the base of the logarithm under both sides. The base and the log will cancel. So I'll get that exponent is whatever I get, then I'll solve. You could notice in the process here that this stuff, that's the inverse of this function. So I found that if f of x is log base 2 of 3x minus 4, that f inverse of x is just written right down the side here. I start with an x, I put a 2 under it first, then I add 4, then I divide by 3.
Nice.
You guys see that? So no need for bubbles, right? Those kind of bubble diagrams we were doing before. If you're solving for something, you get one of those bubble diagrams automatically. It's just the steps you're doing on the side. Cool?